In this video, we'll look at Booleans. So what are Booleans? Booleans are true or false. So true here is true. So I just run that and say it's true. And you see that it's in green and it's recognized by Julia. The big difference with Python is that in Python, you'll have a capital letter T. In Julia, it's a small first letter for true and for false. Now, false is false. And then you'll use that to actually know if something is true or false when you use comparator. And we'll look at more comparator at the end of this video. Here are a few. So if I say 1 is superior to 0, well, that's true. 1 is superior to 0. Hence, I receive a Boolean, which is telling me true. And I can use that then in my code. Then if I want to check if a number or a variable is equal to another variable or another number, I can do like this. 10 equal to 10. So why equal? Why not just 1 equal? Because 1 equal, we already use it and we know it is used for assigning something, a value to a variable. So you need something else to do the equal comparator. So what is used in many languages is equal. When I use double equal, it means that I'm actually comparing those two variables or those two numbers in that case. So here I'm saying, hey, is 10 equal to 10? And the answer is yes, it's true. Now, to say not equal in Python and in Julia, we use exclamation mark equal. It means not equal. So if I say, hey, is 10 not equal to 10? It's false because 10 is equal to 10. Now, there are functions that I can use that also give me Booleans. For instance, this one is integer. So I create one variable, x, and assign 1, 2 as value in this variable. And then I check if x is an integer. So I assign 1, so it's going to say true. Now what happens if I put 0, comma 0? So it's actually going to say true still, because the way the function is done, it's actually checking if I'm a float with something after the comma. So if I add a 1 and it's 1.01, then it's going to say false. I say, no, this one is really not an integer because it is a float. Cool. So I can delete that and we'll keep x as 1 and we'll go to the next one. So what are logical operators? So when you have true or false, when you have Booleans, in general, you want to combine them. You want to check if something is a cat or a dog. If it is somebody with a driver license and is more than 21 years old. So you need this combination of condition to know if actually the full package of condition you're interested in is met or not. So you got a few, and we'll look at two here. So you got and. So with and, you want everything to be true, right? Like for instance, I want you to be adult and have a driver license for you to be authorized to drive. You need both. If one of the two is false, then everything at the end of the day is false, or the result is the same as if everything was false. So here, if I got false and true, it's telling me false. But if I have true and true, then it's true, right? So everything needs to be true for this to be true. If there is one false, and we can have many and, then everything will be false. Or it's kind of the opposite. Or is, I want to know if something is an animal. And I can say, hey, are you a cat or are you a dog? And if it's either a cat or a dog, then it's good for me. I don't care if it's not the other one. So here with we want to check that everything is false so that it is false. If I got one true, then everything is true, right? So false or true, that's true. Now, if I had it the other way around, and I invite you to play with the code, you got it on GitHub, remember, it would say the same. Now, if everything is false, that's the only way you can get false with an or. I'll go back to true, and we'll continue. So there's something in Julia called short circuit, and it allows you to use the way Julia is looking at this operator, because if you got an and you know that everything needs to be true, if you got a false, then you don't need to look at what's coming next. Anyway, you got a false, not everything is true, so the answer, the result will be false, and vice versa with or. We'll look at it. So first with and, if I got false and then something, doesn't matter what it is right now, then it's telling me false. Julia is ignoring all that part. All that from the end is ignored by Julia. It doesn't look what's happening here. Now, if it's true and we're using and, well, Julia doesn't know what's coming next. And if you want to answer true or false, you need to know what is coming next. You need to know if you got one false or if it's true also. So this one is true, so we're fine. But we need to evaluate the next sentence, the next line we got here to actually know if this the full statement is true or false. So here we got true, then we cannot ignore what is coming next. So we're actually looking at it. And it says println I. Okay, so Julia is writing hi. And then it finally says true. So with the semicolon, we're actually starting a new statement and we got true. And it says true because we got true, and the println was executed as well as everything we got between brackets here. Now, we could do exactly the same with that kind of text, and actually we can do it with errors. Right now I will do it with text and printing the text so that we don't have like huge red mark everywhere, and I'll show you at the end how to do it with error. So let's create x equal 1. X equal 1, and we'll check x. If x is superior to 0, which is going to be true, then I need to check the next expression because it's and everything needs to be true, or I need to have a false to stop. So here, this one is true, hence I need to check the next one. And if it's not clear, just play with it and you'll start to understand it. But the thing is basically, if something is giving me the answer of the full package, and I don't need to look at the rest. If it isn't, then I need to look at the rest. So here, this one is true, and I need to check the next one to see if it's true or false, and it will print the message. But I can use this in Julia to actually create an error or print some text. And here, for instance, it says, hey, x cannot be greater than 0. And here it is greater than 0. So if I put x equal or minus 1, then it just says false, because this was false, and I'm not printing the rest because it's being ignored, because anyway it's going to be false. So that's how it can be used. Now let's look at exactly the same with or. So it's the same, but kind of reverse, right? Because if it's true, then everything is true, and I don't need to look at anything else because it's or. It's this or that. Yeah, one is good, then everything is good. Cool. So true, I don't look at the rest. But if it's false, well, I need to look a bit further to see if I find a false or a true, because that's how I know what will be the final result. So here I got false or something. So I need to look at this something this time because I had false. Println hi, well, I'm just executing this. Now we can do that with something a bit more useful and say, okay, is integer x, and x was equal to 1. I can just add it here so it's actually clear. X is equal to 1 is integer x, that's true. So that's just true because it's an or. If it's true, then I don't need to check what's happening next. Now, if it's not an integer, here we got a float here, then this will give me false, and I need to check what is coming next, and I can use it with a print like here and say, hey, no, x must be an int. So here we printed everything, but actually in Julia you can do like in Python with raise exception, and you can create your own error. So the code will stop, and you just do it like this. It's super easy. Error, then bracket, and then what you want to write. When you run that, I created my own error. Well, it just created a real error, all red everywhere, and explain why you got an error. And that's why I didn't use error everywhere and I used print. But technically what you really want to do is this, is integer x, and if it's not what you wanted, then block everything. There is an issue with your code or what will they give you, and you can just stop everything. And here we had x, I can't put it here because we don't see it anymore. X is equal to actually a float, doesn't matter which float. So this one is false, and this one will run and will stop everything. If this was true, then I don't have an error, right? So that's how it can be used. I don't have an error and the code can continue. I just have a true. And again, if I got an issue here, well, a float, and I'm checking if I don't want a float, then I got this error with the explanation of why I created this error. Now let's look at the different comparators that we have. We already seen this one, right? 1 equal 1. Now I'll add 1.0 and it says true because 1 is equal to 1. Now if I want to actually check the type, you can do this in Julia like you can in JavaScript, which is triple equal. So that's a lot of equal. So why do you have so many equal? Well, that's because you don't want to just check the value and check if 1 is equal to 1. You also want to check if the type is the same. So here on the left I got 1 as an integer, on the right I got 1 as a float. So it's not programmatically identical. It's actually different in type. So here's going to tell me false. So if I want to check even the type, I can do triple equal. Now, if I want to do inferior or superior, inferior to equal, it's with those symbols, like the mathematical signal symbols. So 3 is inferior to pi, that's true. And is 1 inferior or equal to 1? Well, that's true because of the equal. If I remove the equal, then it's false. Whoop, I put it back and it's true. Now let's look at this. 0.1 or dot comma 1 plus comma 2 is actually the same as 0.1 plus 0.2. Right? So this is true in Julia, this is true in Python, but look at this number. It's actually not giving me a perfect 3. So 0.3. Why? Well, that just the way that the float are saved in the memory is something that makes that they are not absolutely perfect. That's something you study in computer science. Don't worry too much about that. Just know that in Julia, because it's so much focused toward mathematics and computing, if you do 0.1 plus 0.2 equal to 0.3, it says false because it's actually not equal, even if it kind of should, right? Now you got this symbol which says approx is kind of equal, you know, with the little wave, and you can create it like this, like we've seen before. Then it's gonna say true. So that's super useful. Now let's look at that. You can do a combination of everything we've seen before, and you can say x is equal to 42. So then we can change this number, but we'll just set it as this value. And now we can do all this comparison and or a mistake, an error, something that will stop the code. So what happened here? There's no issue because this is true, and we're speaking of an OR. The OR wants at least one true, and if you got one true, then it doesn't look at anything else. So we're fine. So if I change the number, it's still fine. Now if I do 101, or technically 100, because here we don't have an equal, then I got my error telling me, hey, no, you must be between 0 and 100. So I kind of block the code, and we don't have bigger mistake later on because somebody put a number it was not supposed to do. I put back 42 and it works. Now we already seen this one, but just to see all the comparator here, if it says something that you want to compare, so that you want to know if it's not the same value, then you'll use exclamation mark and equal and give you false if it's exactly the same. But if the value is different, then it will tell you it's true. So here you're asking, hey, is 1 exactly equal? Is 1 not equal to 0? Well, that's true, it's not equal to 0. So that's it. We've seen the Boolean, the comparison, and all the short secret. It's what we needed for this lecture. So I see you in the next one. If you reach this part of the video, you should consider subscribing to the channel so you'll be aware when the next one are coming. And well, please comment and tell me what you think about all this. And if you got any question, I'm happy to answer there in the comment. See you soon.